Welcome back. Thank you for continuing 8.2 with me. So today we're going to finish off these 8.2 notes, our day 2. Now, yesterday we were talking about distributing a monomial into a polynomial, multiplying them. Today's focus is factoring. Now, factoring, what I mean is pulling out, or you can think of it as pulling apart when we get further into factoring. Now, before we get too far, let's just really quick review what we're talking about. So yesterday, we were focusing on multiplying it in. So something like 3x times x squared minus 6. So to distribute that in, we would take the 3x, multiply it to each term. So 3x into the x cubed. Well, the coefficients 3 times 1 gives us 3. Now for the exponents, x to the first and x squared, 1 plus 2 gives us an x cubed. And that 3x times negative 6, well, 3 times negative 6 gives us negative 18. We have that x, and there's no other x multiplying it, so it just stays x. So that was our focus yesterday. Now, when we talk about factoring that, what we want to do, we want to break it into a product. We're in search of the GCF, which means greatest common factor. So we're searching for the greatest common factor. And a little note for you, distributing and factoring can be thought as undoing each other. They're opposites of each other. So distributing is putting it in, factoring is taking it back out. Now, when we're looking for the greatest common factor, we need to find the largest number that can divide both of the coefficients in the highest degree the variable that fit into every term. So, let's do some examples of this. So that 5x cubed minus 10x squared plus 35. We want to find the greatest common factor. So the first thing I'm going to look at are the coefficients, 5, negative 10, and 35. I need to search for the greatest number, the largest number that divides all of those. Well, 5, 10, and 35, if you notice, 5 goes into each of them. 5 divides each of them. That is the largest number that will divide each of them. My next focus is on the variable. I want to find the largest exponent that's in every one of them. So here we have an x to the 3, x to the 2. Well, here notice we're missing something. There's no x. Now, if there's no x in one of the terms, there's no variable, well, that means the GCF does not include the variable. All right? So in this case, actually, the variable is not included in the GCF because you can't pull the variable out of that last term. That 35 doesn't even have the variable. So in this case, the greatest common factor is actually just 5. Now, let's take a look at the next one. So the first thing that I want to do is look at the coefficients, negative 3, negative 12, and 18. And I want to think to myself, what number divides each of them? Okay, what's the largest number that divides all 3 of those? Well, I think you'll find the answer is 3. 3 divides all of those. Now, let's focus on the a's. So I have a to the first, a squared, and a to the first again. So what's the largest one that's in all of them? Well, 1. Because we have 1 here and 1 here. So those only have 1 to give. So the GCF can only have an a to the first. Now let's look at the b's. So I have a b, b, and b. So all 3 of them are just b to the first. So that's the largest one you can pull out of all of them. So the greatest common factor just has a b to the first. And when we're looking at that c again, Well, the C isn't even represented in every term. So because it's not even represented in each term, we can't include it in the GCF. So this one, the GCF is really 3AB. All right, so our next kind of critical thinking exercise, we want to create a binomial that has a GCF of 8x squared. So that 8x squared is like what we were putting over here. So what that means is we want to construct a binomial. Binomial meaning two terms, and it has a GCF of 8. So when I'm constructing this, what that means, that 8 is going to be the largest number that divides both coefficients. So I'm going to put in one of my coefficients as 8. Another coefficient, I'm going to do 24. Because again, looking at those two numbers, 8 is the largest number that divides both of them. And then x squared. All right, so x squared is going to be the largest exponent of x that can pull out of both. So if I call this x cubed, well then this one has to be x squared. Because you have to go with what can pull out of both. Well, between x cubed and x squared, you can only pull the x squared out of both of those. And now I've thrown my addition sign to make it a binomial, and I've constructed the polynomial. This polynomial has a GCF of 8x squared, because 8 is the greatest thing that divides out of both of my numbers, and x squared is the greatest term that can pull out of both of these. All right. So once I can find the GCF, you can factor a polynomial. So let's factor the binomial that I've just created above. So we're going to get back to that because I want to show us some notes first. So what I mean by factoring, we are going to pull it out. Now, the first thing in factoring is we need to be able to find that GCF. That's the first step of factoring. All right, so first we're going to look at the two coefficients, 4 and 12. What pulls out of there? Well, between 4 and 12, the largest number that divides both is going to be 4. And now we have x cubed, and then the 12 doesn't have any x. So again, x isn't going to go in our greatest common factor at all, simply because you can't pull it out of both terms. The 12 doesn't even have an x. So 4 is that greatest common factor. Now, in the factoring process, what we're going to do now, we're going to pull that 4 out of both terms. All right, so what does that mean? Well, I have 4x cubed, and I'm dividing 4 from that. Well, if I'm taking 4 out of that the 4x cubed, all I have left is x cubed, because 4 divided by 4 cancels. Now, with that negative 12, if I'm dividing a negative 12, or if I'm dividing 4 out of that negative 12 divided by 4 leaves me negative 3. So basically, to factor, once you find the GCF, divide it out of each term. So now you can always check your work too. So to check my work, I'm going to quickly distribute it back in, all right? So 4 times x cubed gives me 4x cubed. 4 times negative 3 gives me negative 12. And notice, I got back what I started with. So what that means is this truly is the factored form, okay? You can always check your work to make sure you did it right. So let's try this process again for the next one. 12p squared minus 8p minus 6q. All right, so looking at this, first I want to identify the greatest common factor. So I look at the 12, the negative 8, and the negative 6. And I think to myself, what number divides 12, negative 8, and negative 6? Well, looking at this, you might think 6 at first because of the 12 and the 6. But the 6 doesn't divide the 8. So that can't be what we're looking for. You may think 4 because 4 divides 12 and 4 divides 8. But 4 doesn't divide 6. So as you're looking for this number, it may take you a little bit, but I think you realize in this case, the greatest number that divides all three of those is actually just 2. 2 divides 12, 2 divides 8, and 2 divides 6. So this will come with practice, okay? It can take a little bit to practice these skills, but just work at it, all right? Now, in terms of the variables, so I have p squared, p, and then no p in the final term. So again, we talked about p isn't going to be part of our greatest common factor then. And then I have a q in the last term, but there's no q in my other terms. So again, q can't be part of it either. So in this case, really, the greatest common factor is just 2. So I'm going to pull a 2 out of every one of those terms. If I pull out, I mean I'm going to divide it out. So 12p squared, if I'm dividing it by 2, 12 divided by 2 just gives me 6. Then I leave the p squared. Negative 8p divided by 2. Well, negative 8 divided by 2 is negative 4. Then again, the p just stays along for the ride. Negative 6q, and I'm dividing it by 2. Well, negative 6 divided by 2 is negative 3. Then again, we still have that q. So I've divided each of those terms by the 2 that I'm pulling out. All right, and again, you can always check to make sure that you've done it right. So I'm going to redistribute it to double check my work. 2 times 6p squared. 2 times 6, well, that gives me 12. And then I still have my p squared. 2 times negative 4p, well, 2 times negative 4 is negative 8. Then the p stays along. 2 times negative 3q, 2 times negative 3 gives me negative 6. And then the q stays. And if you notice, you got exactly the same thing, meaning that this really is the factored form. So I think I'm going to stop there for us. We can finish up those last two in class together. All right, so thank you for joining me for this notes video, and I will wrap this up in class with you.